Hi everyone. Uh, so this is the part three of visual assessment lecture. So we're going to look at the reading charts. So before we go into one by one, the reading chart that is available for us to do assessment on low vision patients. First of all, you have to know what are the different charts that is available. Okay. Number one is the format. Okay. The reading chart differs in the format and also the notation. Okay. Format means it can be only words, okay, that can be found in the reading chart, or it can have a meaningful sentence and also no meaning sentence. Okay, meaningful sentence means is my name is Indira. No meaning sentence means is in like Indira, ball, flower, butterfly. Okay, so there is no meaning in the sentence, but it is arranged in the sentence form. Okay, while words is like it is arranged only word by word, like Snellen chart is letters, right? This one is words. Okay, so it depends in the format. And then the next one is the notation. So there are many notation that is available. Okay, that is used, to record down the near VA, like logma value, M unit, N unit, Jagger unit, decimal. Okay, Snellen fraction. So there are many units available. Okay, that exist. So basically, what only rules when it comes to this DVA measurement is, okay, if let's say the patient comes for the first time, you record it and notation. So when patient comes back, okay, again next time, then you record it in and notation too. Then only it will be easier for you to actually look at the progression. Okay, so that is about notation. Okay, when patient with central scotoma should be tested with various length of words. Okay, because the central scotoma, right, they will have like a black patch at the center of their vision. Okay, if let's say the scotoma is very small, as big as one letter only. So if let's say, for example, if they are looking at the letter, uh, okay, if let's say they are reading the word central, right? Okay, maybe the scotoma is this big only at the end only the N is missing. Okay, because the patient able to get the words from the site. So when N is missing, they're still able to make the word. Okay, if let's say that scotoma that another patient B is having, and it is as big as this four letters. Okay, so patient might tend to miss the words while they are reading. Okay, so if let's say if it is small, then we still know that it is, if let's say it's a different length, right? For example, if let's say, so patient wouldn't know that if let's say, like for patient B, right? So this is actually covering the whole word. So patient might think that patient central scotoma, there is no word in between. If let's say you give like a long word, like for example, meaningful, okay, maybe NING is missing, then patient know that, oh, there is a, four letters that is missing. So that is the reason why it has to be tested with various lengths so that, we know that they really miss the word or not. And then patient might perform with meaningful sentence as they may interpret. Okay, like my name is Indira, right? If let's say the name is missing, but they're still able to know that, the letter missing between my is Indira is the name. Okay, so patient might perform better with meaningful sentence, but usually the charts that we have in the clinic are all meaningful sentence because that is the practical. Okay, nobody reads a no meaning sentence books or any reading material. So usually meaningful sentence is the one selected because it represents the real situation of people reading rather than no meaning sentence. And then no meaning sentence also they have, for some other reasons. Okay, but mostly we in the clinical assessment we use a meaningful sentence. Okay, and then we also have Bailey-Lowy reading chart. Okay, this is how it looks like. Okay, like the first one is the meaningful sentence, while the second chart is the no meaning sentence. Okay, so these charts are in the English language. Okay, the words charts use unrelated words, and each size level there are around about 10 words arranged in 2 rows. So all these has, like this one, all these has 2 rows, while this one has 3 rows each. Okay, so they standardize the number of rows. So the sentence chart, this is the word chart and this is the sentence chart. Use sentence that have 60 character spaces arranged in 60 rows. That means this whole sentence should have 60 character spaces. Okay, so all of them have 60 current character spaces arranged in 2 rows. Okay, the words and sentences are at the third grade level and they were selected or composed by school teachers. So they don't randomly do this charts. They don't simply pick any words. Okay, they pick words that can be understood by a third grade level kids. Okay, so it is actually made very easy for people to know, what is that word means, okay, or able to read that. So they don't give a very complex words, okay, so they give a very simple one. Okay, they lay out as a left justification, and there is close spacing from one size level to the next. Okay, so the size between, the spaces between the lines, right, they also decrease, according to the, get smaller systematically according to the font size. Okay, the size of progression is in increments of 0.1 logma, similar to the distance Bailey-Lowy chart, the logma chart. This one also have the similar log unit. Okay, the font use is Times New Roman and the size ranges from 5 m to 0.1 m. Okay, another thing that you have to know, there is a conversion formula for m unit to n unit. 1 m equals to n8. Okay, so it is from n40 to about n12, n1.2 something. Okay, so it is actually a very systematic chart and also very comprehensive and very systematic, because the size of the letters, the choice of the letters, the spacing between the letters, the character space between the letters and words are systematic, okay, or constant. Okay. Next is Read or Minnesota low vision reading chart. Okay, this is also meaningful sentences chart. It consists of 19 sentences printed at progressively smaller sizes. It starts from 1.3 logma up to 0.5 logma. So each sentence has 3 lines with same number of characters or line. Okay, all 3 have the same number of lines and same character also. Okay, so this is also another chart that is commonly used in low vision clinic. And the most commonly used in our clinic would be the column render continuous text reading card. Okay, so the letter size starts from 6.3 m to 0.32 m in Times New Roman. Okay, so this is how it looks like. It's a two sided card. So the first one is the biggest one, and then it gets smaller, and then we flip, then we'll get a smaller version. Okay, this card is actually a 40 centimeter long card, but okay, when it comes to low vision assessment, right, we don't use this card. Okay, we use this card for normal people who reads at 40 centimeter. While for patients who are low vision, we allow them to read at their habitual reading distance. We don't test their near VA at a standard reading distance. So this card is not used in the low vision clinic for near chart. Okay, any near chart that comes with a card, it is not used. Okay, it is used for a standard one only. Okay, another chart is the low vision letter chart, which I already explained just now. Okay, the frontal part is the distance chart and the back part is the low vision letter chart, which is for near. Okay, so it contains proportionally spaced reading segment from 4 m to 0.6 m in Times New font, Roman font. Okay, from 3 m on, 2 sets are provided. Okay, so from 4 m, it is only one is provided. Okay, then after that, from 3 m on, 2 sets are provided. So each VA has two sets, okay, to avoid memorization. Okay, each line contains the same number of letters and spaces. Okay, similar to the distance chart. Most acuity vision charts have the patient identify single letters in a line. Okay, and then continuous text are designed to simulate everyday reading tasks for patient by using actual sentences. So this is the reason why, okay, mostly in the low vision clinics, okay, we only take the meaningful sentence chart because that is the one that practical for everyday tasks of a patient, rather than getting a no meaning sentence is more for research work. Okay, so these sentences are calibrated to have a specific number of letters and spaces to create an equal test. So each of this line has the same number of, a specific number of letters and spaces, so that all these tests are equal between the lines. This is also another type of near vision chart. Okay, Lia numbers near acuity chart. So this is like the digital version, okay, that we have. Okay, now we already look at the distance chart, sorry, near VA chart. So as I mentioned on the near VA chart, it is near VA chart is basically for um, to measure the VA of the patient. So as I mentioned in this previous video, what we measure when it comes to the near VA is, one is VA, another one is the reading speed. Okay, and also we have like many charts that is available. Okay, the reason why we don't use the standard Hoya or not standard, the Hoya or Asino charts is the biggest VA that they have is very limited, either N14 or N16 only. While with this standard VA charts or more comprehensive near reading chart is, you will have a higher VA also can be tested with the chart. So that will be very helpful for patients who are low vision, because we can't expect them to achieve the VA level of the normal people. Okay, so the procedure here is similar to the distance one. Okay, measure the better seeing eye VA first, and then the reading measurement. So how do we do this is, okay, when we want to do the reading measurement, first what we have to do is ask the patient to close the eyes, keep remaining close the eyes until they instructed to open the eyes. Okay, so once they already close the eye, give the reading chart to them and make sure they don't open their eyes yet. Okay, and then ask them to hold at the habitual reading distance of them. Okay, so if let's say it's at, when they close their eyes, so they will be able to estimate that, okay, usually I'll read at this distance. Okay, so once they already mentioned that this is the reading distance of theirs, then measure the reading distance. So once already measure the reading distance, then what you do is you occlude the bad eye. Okay, make sure at that point of time they are wearing their reading glasses if they have. If they habitually use their reading glass to read, then ask them to wear that. And then occlude the bad eye, and then ask the patient to read at the similar. So throughout the assessment, the same reading distance has to maintain throughout the session. Okay, so then after that, measure the best VA that patient could read, and then worst seeing eye, and a similar thing, worst seeing eye, and then measure the VA of the worst seeing eye, then the both eye VA, and then the last one is after the both eye VA is actually um, uh, you have you have taken the reading. Then the next thing that you have to do is ask patient to go to one line above the best VA for both eye, and then ask them to read the line, and then you record down the time and see how many words that they can read in the 60 seconds. Okay, then we are done with the near VA taking. Okay. Okay, now move on to the refraction. Okay, before that, one second. Let me check if it is recording still. It is recording. Just give me one. Okay, next is first history taking. After done with history taking, then we continue with visual acuity taking. Okay, so after visual acuity taking will be the okay. So after that will be after VA taking for distance and near. Then the next one will be the refraction. Okay. So refraction is one thing that you have to remember. Refraction is only performed if, let's say, the distance VA after the pinhole measurement shows a significant improvement in the VA. Okay. Otherwise, we don't do refraction on all patients. Okay. It is based on the need, based on the VA, and based on the history taking. Okay. If let's say in the history taking patient has no complaint related to the distance VA and all that, it's okay. Then no need to do. Okay. If let's say the pinhole shows no improvement. If let's say patient complain blur, but then when you do pinhole measurement, it's not showing improvement, you just adapt. Okay. Or the pinhole measurement shows improvement by one line. Okay. Then do the refraction. So basically, we don't do refraction on all patients. Why? Because one is the result is not reliable. Second is it is actually very tiring. Okay, so it is time consuming too because VA itself take longer time to complete. Okay, imagine refraction. Okay, which is involving a lot of vision. So it's going to be maybe very tiring for the patient. Okay, and it's not necessary also. Okay, when it comes to this retinoscopy, okay, first of all, always begin with the habitual correction. Okay, if let's say patient comes in with glasses, okay, ask them to wear the glasses and put a Halbert clip before you start with your retinoscopy. Okay, or otherwise, if let's say you don't have Halbert clip, you just do forcimetry checkup with the current glasses, and then transfer that to the uh, trial free, and then you can actually refine retinoscopy based on that. Okay, so and always remember that this habitual correction that the patient is wearing, right, it is not the good eye is the could be the optimum power, but the bad eye is, it can be the power of the eye, or it can be a balancing lens also. Okay, so just keep in mind that the bad eye uh, refraction, it is not the accurate one. Okay, just have like a thought on it whenever you do the forcimetry before the refraction. Okay, and then next one is assess refractive error objectively if possible. Okay, this is very crucial to have a good retinoscopy skill. Okay, the reason why is because subjective refraction is going to be super tiring. Okay, super tiring because it is going to take a very long time, and then patient can be very slow in giving response. So that is the reason why I say it's difficult. So assessing refractive error objectively would actually make things easier, when it comes to um, subjective refraction later. Okay, so what is the technique that we use? What is the retinoscopy technique that we use to perform retinoscopy on patient is radical retinoscopy. Okay, radical retinoscopy is performed if reflex is dim. Okay, for example, if let's say you do retinoscopy, usually they will do it at 50 centimeter. Lah. Okay, so at 50 centimeter, okay, if let's say you're doing at 50 centimeter, And when you perform that at 50 centimeter and you see the lights are very dim. Okay, if you see the lights are the reflex is very dim. Okay, even after you put high minus lenses, power lenses also, still you don't actually able to see the reflex, reflex when you perform retinoscopy. Then what you do is you move closer a bit, okay, closer to the eye until you able to see some reflex in the eye. Okay, if let's say you able to see the reflex at 20 centimeter. Okay, so what you do is you perform the retinoscopy at 20 centimeter, okay, until you see the reflex is neutralized. Okay, then what you do is you move back to 40 centimeter back. Okay, so 40 centimeter back and see now you can see the reflex or not. If let's say now you can see the reflex, you neutralize it again. If let's say even at 40 centimeter after correction, after retinoscopy neutralize at 20 centimeter, okay, but still at 40 centimeter, you're not seeing any reflex. It's okay. Okay, it's okay. Just record it down. Okay, and then for the first method where, for the first method, you just record down the power. That means you do at 20 centimeter and then you come at 40 centimeter, can see reflex, you refine again until neutral, until it become neutral. Okay, then you just record down the power. While for the second case, okay, after you do the radical retinoscopy, you try to already neutralize, you bring back to 40 centimeter, you don't see any reflex. So what you do is record down the 2-meter result and try to convert them, okay, with the compensation power for the, uh, from the, if let's say it is done at 20 centimeter, right? So compensate the distance that have been reduced to the power. Okay, so that would be the retinoscopy, or how to do radical retinoscopy for the. So that means the radical retinoscopy is when you move closer, okay, and then you try to refine it until you can see clearly. Okay, so that is radical retinoscopy. Okay. Okay, next assessment is keratometry. Okay, keratometry is uh, performed on patient who has high cylindrical correction, like patient who are aphakic patients. So this kind of patient must do keratometry, although it is not compulsory. But nowadays, patients have high cylindrical corrections, like aphakic patient, even youngsters also. Okay, so what we can do is, if let's say the cylindrical correction is found to be, high, then keratometry can be conducted. Okay, that one also depends on the cooperation of the patient. Okay. Okay, next is subjective refraction. Okay, when it comes to subjective refraction, okay, this one is totally different from the original subjective refraction that you have been doing and also learning for a very long time. Okay, so this one first different is we are not using 6 meters Snellen chart. We use a 4 meters, Lokma chart here. Okay, that itself is different already. Okay, so how do we actually do this subjective refraction is make sure patient able to read 3 to 4 lines on the chart. Okay, reduce the distance if necessary. That means if let's say patient able to read the 4th line from top, okay, 4th line from, number 1, line number 1, 2, 3, and 4. If let's say patient able to read the 4th line, okay, then what we can do is, okay, maintain at the 4-meter chart. When you do a refraction, subjective refraction, you have to do it with 4-meter chart, not 3-meter chart. So you put it at 4 meter and then you continue do the subjective refraction. If let's say at 4 meter patient only able to read 1 line only, okay, then what you have to do is you try to move it 3 lines. sorry, that means if let's say the patient only able to read the first line, you move from 4 meter to 2 meter. Okay, and then see if patient able to read 3 to 4 lines or not. If let's say patient able to read 3 to 4 lines, then it's good enough already. You do the subjective refraction at 2 meter. Okay, which I will teach later in a while, how to do it. Okay, so that's how you do it. Number two is encourage patient by telling them that they are doing better than expected. Okay, this is very much needed. Yeah, patient need some motivation to do the very complicated assessment. Okay, whether one better, two better, and all that. Right, it's going to be very tiring for the patient. So always boost them up with some positive words so that they will feel better in cooperating with you. Next is patients should be given a longer time to make judgments and do allow eccentric viewing training. Okay, so patients should be given longer time to make judgments means, okay, if let's say you're changing two lens, right? Ask patient one better or two better. Make sure that you give them a longer time to, you cannot force them to, hey, faster tell, why taking so long? You can't say that. Okay, because some patient, after they focus for a very long time, they can see the word or letter. Okay. Some patient, after focusing so long also cannot get it. Okay. So there are different kind of patient. The patient should have a longer time to make judgments. You allow them, don't restrict them, say that fast, fast and all that. So let them do. Okay. If let's say that patient is actually having a head turn or eye turn, then we need to, if let's say the patient have eye turn and all that, patient should be allowed to do the to have the eye turn or head turn. Okay, so that we, usually the eye turn and head turn make the vision uh, maximize their vision because at that particular point, they can see the best. Okay, so we also, when we do this subjective reflection, we want to help them to see better in that angle. Okay, so that will be one. And then if the refraction has been carried out with closer distance, final refractive error will be over plus. Okay, so what happened is if let's say uh, patient power is patient's power after do refraction at 2 meter is -2. Okay, so the final refractive error, maybe it becomes minus 150. Okay, because the final refractive hour will be over plus. Okay, sorry, yeah, over plus. So that means if it is -2, then the patient will be like about -1. Okay, correct. What I say is correct. Okay, then what we do after you already do distance refraction, okay, which I already taught in the classroom. So once you already do a distance RX correction, already get the power, then we shift to the reading addition. So the maximum that we can give for a reading addition is plus 3.5. Cannot be more than that. If it is more than 3.75, it will be 4 diopter, and that 4 diopter is already considered to be a magnification tool. So we don't prescribe more than 375. Okay, for reading addition. Okay, so how do we do this reading addition? Is simple. Just put a +1, ask patient which one is better, with or without. If let's say patient says +1 is good, then you move higher until patient is reversed. Okay, so patient already reversed, then you stop. Okay, so that is the reading addition of the patient. It is try and error. There is no like a proper way of actually, like NRA, PRA, age related, it doesn't work because the patient can be young patient who's like only 2 years old, 3 years old, up to age of 60s, 70s, and 80. Okay, so that's how we do the reading addition. Okay, now we move on to the procedures. Okay, so the procedures, okay, when it comes to subjective refraction, refraction starts with purpose and instruction. Okay, tell the patient why you want to do refraction, because when it comes to low vision patients, right, they are very tired of doing this assessment at many places. So when they come to your place, they would expect, to skip this retinoscopy and subject to refraction because it's very tiring. It takes a lot of time. Okay, so first is introduce, why, this visual acuity, why this refraction is performed. Okay, so what are the things that we need to do while, refractive error is measured. Excuse me. Okay, so first start with the retinoscopy with habitual RX. Okay, retinoscopy with the habitual RX. Okay, if let's say possible, do it at 50 centimeter. If let's say patient is actually seeing uh, sorry, at 50 centimeter. If let's say patient is not seeing the reflex, then they can move to 2 meter. Then if let's say after they neutralize it, they can try back at 4 meter and see whether uh, can see the reflex or not at 50 centimeter. If let's say they can see the reflex, then go on with that, neutralize it, prescribe. If let's say cannot see, or patient is not able to see anything at, the examiner not able to see any reflex at 4 meter, then use that 2 meter result and then convert it to the over plus power and then put inside the trial frame. Okay, so once you already put that, compensated power, then you measure the VA like normal. Okay, the better seeing eye, the bad eye. Okay, similar both eye VA, and then the pinhole measurement similar. And then you calculate the comparison lens. Okay, so as I mentioned during the physical class, comparison lens is measured, and then try to achieve the best sphere of the patient. So once the sphere is achieved, then JCC and then VA measurement. Okay, so this is how we do the refraction on patient with uh, low vision. Okay, so that's about the procedure. Okay, next we move on to contrast sensitivity. Okay, when it comes to this contrast sensitivity, okay, contrast sensitivity test is not compulsory in other clinics, but in low vision clinic, it is compulsory to perform contrast sensitivity in all patients. Okay, the reason why is when there is a damage in any part of the eye, right? The first damage will happen, not first damage, okay, uh, not the first damage, I would say. Okay, if let's say some changes happens to the retina, right? Okay, so when the some changes happens to retina, when the retina, you know, functionality is actually lost, right? So the first thing will actually drop is the contrast sensitivity value. Okay, and then only the VA drops actually, will be observed. Okay, so that is the reason why contrast sensitivity has to be done or performed on all patients, because with the contrast sensitivity result, we will be able to know, number one, how bad is the vision is affected. Okay, how bad the vision is affected. Okay, number two is we will be able to actually, um, monitor the progression of a disease. Okay, patient might complain that, oh, I cannot see, compared to my previous visit vision and current vision, I think the current vision has dropped so much. I have so much of difficulties in seeing things, clearly and all that. So, but when you measure the habitual VA, you find that the VA of the current one and the previous one is similar. Okay, so it doesn't show any VA difference. Okay, so because VA will take time to drop, while contrast sensitivity will drop immediately. So if let's say that last visit contrast sensitivity test is performed, we can compare with the current one, and we could see the changes there. Okay, when the cones are affected, okay, or the central part is affected, the sensitivity of the macula will drop first, okay, or the sensitivity of, any region, anywhere in the retina will, when the contrast sensitivity will drop first, then only VA will actually drop. Okay, so sorry, that's what I want to say. Okay, so VA is not a complete description of visual performance because it does not deal with patient's ability to detect large objects and low contrast. Okay, so when it comes to VA, although it is the first measurement that we do for all patients, but for this particular reason, okay, it is not a visual performance. Okay, so that is the reason why we need to do a visual performance on this patient to get an idea of what kind of, problem that they face because of this. Okay, so therefore, contrast sensitivity claimed to provide a better assessment of the patient's true functional vision. So lowered contrast sensitivity impairs patient's ability to see the steps, curves, and irregularities in the pavements. Okay. Excuse me. Okay. So there are many charts that we have, to test the contrast sensitivity. Okay, one of the tests is this complete Rabin contrast sensitivity chart. Okay, it is comparable to the small letter contrast test. Okay, it detects a subtle effects of defocus, low vision, low illuminance, and glare. Okay, so this chart, the log contrast sensitivity increased from 0.25 steps per row. Okay, and each line on the Rabin contrast sensitivity test is lower contrast than one or before it. Okay, using the log CS steps. Okay, the progression in contrast help to identify the patient's contrast sensitivity. Furthermore, the test help to detect the subtle effects such as defocus and low luminance and glare. So contrast sensitivity test is also important in determining the magnifiers or devices that we're going to prescribe. If let's say the patient is having extreme glare problem, right? Okay, that is because of the contrast is actually very low. Okay, so for this kind of patients, right, additional lighting can actually help this patient. Okay, additional lighting, if let's say the patient is having contrast sensitivity issue, right, the images that they see is no clarity and it's not bright enough. So that is the reason, okay, these patients will actually, benefit from additional lighting or devices with built-in illuminations, okay, like a stand magnifier, illuminated stand magnifier, illuminated handheld magnifier. So any magnifier or any, glasses that is provided to them, okay, will help them to see better, okay, uh, with the help of the additional lighting. Okay, so this is also another reason why we do the contrast sensitivity test, whether to know whether the patient is having, any progression, okay, any problem, okay. Then from there we can prescribe any devices or any aids with the illumination built in. Okay, next we also have this Richmond Sloan low contrast chart. Okay, it is a standardized based on ETDRS-VA charts. Okay, the letters are designed to be equally detectable from normal observers. Okay, each line has an equal number of letters similar to the Lockma chart, just that it is actually faded by percentage. Okay, change in VA from one line to another occurs in equal logarithmic, okay, steps. Okay, change of 3 lines constitutes a doubling of the visual angle. So it is available in 4 contrast levels. Okay, and when you use any of the contrast sensitivity chart, right, you cannot touch the chart. Okay, the reason why, just remember because our FACT and also our palindropsin chart in the clinic, right? It is actually contaminated already because student has been pointing out the letters and all that. Okay, but supposedly when it comes to contrast sensitivity chart, shouldn't actually touch the chart because your fingers might be contaminated. When you actually touch and point the letter, it might actually uh, touches this area or touches this area, which will lead to the contamination of the chart. So any chart related to contrast sensitivity or even VA chart, shouldn't actually, shouldn't be touched. Okay. Okay. Another one is the LIA low contrast sensitivity gratings. It is, it measures contrast sensitivity at 5 contrast levels. Okay, 25%, 10%, 5%, 25%, and 1.25%. Okay, it is measured at 3 meter. Okay, and then once the measurement is performed, then can actually, can be drawn into this recording form. So this recording form, okay, will enable us to actually draw the contrast sensitivity. So from there, it will be very good for the diagnosis also. Okay, why do I say it's good for diagnosis? Because if, let's say, a person is having contrast sensitivity, normal people, okay, so the graph is something like this. Okay, that is normal. If, let's say, a patient is having cataract but no retina issue, they will show the graph to be like this. So you know that once the cataract is removed for this patient, they will be back to the normal one. Another one is if, let's say, the patient is having a cataract and also the patient is actually scared of this. So when they do contrast sensitivity test, okay, might be, the original one is definitely the normal one will be like this. Okay, the one with like the example that I gave just now. Okay, maybe the patient how do I say? So this is normal if, let's say, the patient is having cataract and also fundus problem, right? Sorry, fundus problem. That is the second example. They might actually, have a even lower, you know, lower, pattern in the graph. So from there, we will be able to know whether this patient is after the surgery, they will have a good output or not, or outcome. Okay, because certain patients, they have cataract and also there is a damage at the retina. The expectation is once I remove my cataract, I should see better. Okay, but in reality is they don't see better because at the back of their eye, okay, the retina is already damaged for that patient. Okay, so this contrast sensitivity test, another function is to explain to the patients about the what going to happen to their um, um, how do I say it? Uh, what is the output that they can expect after the removal of the cataract surgery? And also that is one a function of this contrast sensitivity test. Another function of this contrast sensitivity test is one is to check the defect, how much it is affected the contrast sensitivity. Okay, second is to compare, okay, pre and post. Number three is to actually check, what is the outcome that can be expected, after certain, treatment of certain diseases. Number four is progression of a treatment. Okay, if, let's say, patient is given an eye drop, okay, and then after 6 months or 3 months they come again. Okay, so based on the contrast, we can see whether the contrast has improved or not. If, let's say, improved, that means that the tablet that they're taking is actually showing some improvement, so it's working. If, let's say, it doesn't show anything, then it could be like a placebo effect, nothing is there. Or if, let's say, it got worse, means that means this particular, it's getting worse, means the was given for the patient, it is not fully working. Okay, it is causing some other problem. So they will find out a way to, rectify that. Okay. Okay. So that is contrast sensitivity. And last one is glare. Okay, glare is, as I mentioned in the first, history taking part, is glare is one of the uh, serious conditions among the low vision patients, because their glare problem is the extreme level. Okay, so extreme level means it's going to be they're going to cause a lot of consequences for them if they say they're exposed to bright light. So how do we actually do measurement to know whether this patient is really affected by the glare or not? Okay, so the glare it is uncontrolled. There are two ways of doing the measurement. One is the uncontrolled procedures that we usually do in the clinic, or we can do the based on the instrument. Okay, this instruments, but okay, it depends on the clinic whether they have, or practice whether they have this or not. So the uncontrolled procedure is very easy. Just place the test chart against the window. So move the reading chart or move the distance VA chart to the window side, and then ask patient to face the window. Okay, because light is going to come from the window, it is actually going to cause patient glare. Okay, so that will actually make them to not, and we see how much VA is affected based on that. Or another way is, okay, place it at the place it at the normal location, okay, of the uh, visual acuity chart. Okay, ask them to read the letter. While they are reading the letters, we shine light to the eye to induce the glare. Okay, similarly, the first one placing at the near window also inducing glare. Okay, the second one also inducing glare. Okay, and then third one is comparing outdoor activity facing toward and away from the sun. Okay, so bring them outdoor. Okay, put a reading chart and then ask them to sing a song or sing a song. Uh, you know, ask them to read the chart. Sorry, ask them to read the chart. Okay, facing towards the sun. That means if let's say the sun is coming, from this side, so paste the chart. Okay, so that when the patient reads, right, they actually facing towards the direction of the sun. Okay, and then the opposite way. Okay, that means the position of the patient and the sun from one direction, and then the chart is opposite. Okay, so from there we will be able to actually know what happens to the patient's VA, whether it is affected or not when they are exposed to sunlight and then they are not exposed to the sunlight. And then another more systematic way would be the brightness acuity test. Okay, this is the instrument that is used. Basically, it is like a very tiny Humphrey visual field, the hemicircle, right? Hemisphere, thing, right? This one is only, the one is head. Okay, this one is only for the eye. So basically what will happen is this one patient has to hold it in front of the eye, and then once the start button is started, it will actually shine to you, and there is a peephole, okay, where you can actually observe, can look through the hole and read the chart. So then record it. Okay, so and then see how much the VA is affected because of this. Okay, so because of the light, okay, the disturbance that is actually projected to the patient. So that will be the glare test. Okay. Okay, so that is the last test. Okay, now before I end the recording, okay, I'll just like to let you know that if you see the visual assessment that I have shared in this, 3 parts of lecture, right? It is not covering all that. Okay, if you see, there is no pupil reaction test, there is no motility test, there is no confrontation test that I have actually discussed. Okay, the reason why I'm not discussing that is because there is no change in the instrument that we are going to use to measure the patient. And also there is no modification in terms of the procedure. All the test is actually, like a people reaction test, we still perform the same way as what we do for normal people. Okay, if let's say motility test, also the same. Confrontation test, also the same. So I didn't cover the assessment that is conducted as per what is taught to you. Okay, I only cover the assessment that is uh, uh, having a different instrument or new instrument, and also new procedures, okay, to perform. Okay, so before I end the video, I would like to just conclude on the visual assessment. First of all, okay, we started off with a general observation. Okay, so when we look at the general observation, there are um, four aspects that that need to be monitored. Okay, so that we can actually plan our assessment and also our management according to the what we observe, and the observation happens throughout the session. And remember that if let's say you have sent something or recorded something, you can clarify them during the history taking. Okay, and then further clarified during the assessment. Okay, so that will be the general observation. Then comes the history taking. So history taking is divided into two. Okay, there are two history taking, as I mentioned, general history taking and also task related history taking that we perform on patients. So there are general history taking that covering up the topics that is related to the general conditions of the patient. And then when it comes to task related history, it's going to be the particularly daily activities of the patients, on how they actually, what are the daily activities that is affected by the vision problem that they are facing. And then we looked at the measuring the quality of life using the questionnaire, QRL questionnaire, and also we looked at the visual acuity measurements on the charts that is being used, and what is the purpose of actually doing all this. Okay, what are the charts that is actually the new charts, okay, that is created for visually impaired person, and also what is the procedure and what is different from the normal way of doing the measurement. Okay, similarly, we looked at the refraction also. Okay, so refraction also the same. We looked at how to do refraction retinoscopy, similar way, but then we might need to apply the radical retinoscopy, and then keratometry if it is needed. And subjective refraction is already explained during the physical class. Okay, and then we looked at contrast sensitivity. What are the charts that is available? What is the purpose of doing this contrast sensitivity assessment? And the last one is the glare problem. Okay, so as I mentioned earlier, this is not the only assessment that we do in low vision patient. We do many more, but all of them are whichever that you already learned all this while, and there is no change in terms of the method that you use or instrument that you use to actually do the measurement. Okay, so that's all for this particular lecture. So I have completed uh, you know uh, lecture for visual assessment on the vision patient. Thank you.